So this is the response, typical response of practical filter. So it consists of ripples in the pass band, and ripples in the stop band could be there. And of course, if ripples have amplitude A, then it will have some mean value, and this mean value will decrease to its 3 dB frequency, and that is called cutoff frequency FC. Okay. Similarly, in the stop band, there will be some ripples, and the maximum value of the stop band, which is tolerated as stop band, will be having a frequency, let us say Fs. Fs is stop band frequency, and in between Fc and Fs, we cannot say that a filtering action is achieved. So this band of frequency is called transition band between pass band and stop band. So transition band is band of frequencies between cutoff frequency and the stop band frequency Fs, and then pass band is this. Pass band is below Fc and stop band is above Fs. Okay? So above Fs is there is a stop band, and below Fc there is a pass band, but in between Fc and Fs there is no filtering action, and this band of frequency is called transition band. तो इस फ्रीक्वेंसी रेंज में हम जो है फिल्टरिंग एक्शन को अवॉइड, ये नहीं कह सकते कि देयर इज अ फिल्टरिंग एक्शन, यानी कि नेटवर्क फेल्स टू एक्ट एज फिल्टर इन बिटवीन Fc एंड Fs. दिस मीन्स कि ठीक है, फिल्टरिंग एक्शन इज देयर व्हेन फ्रीक्वेंसी इज ग्रेटर देन Fc, फिल्टरिंग एक्शन इज देयर व्हेन फ्रीक्वेंसी इज लेस, filtering action is there in when the frequency is less than Fc, and filtering action is there when frequency is greater than Fs, but in between Fc and Fs there is no filtering action, hence this is called transition band. Okay, so this is typically what is the response of an analog practical filter. ठीक, तो ये सारे पैरामीटर्स होते हैं प्रैक्टिकल फिल्टर्स में. कट ऑफ फ्रीक्वेंसी Fc, स्टॉप बैंड फ्रीक्वेंसी Fs, पास बैंड रिपल A, मिनिमम स्टॉप बैंड एटेनुएशन, ये मिनिमम स्टॉप बैंड एटेनुएशन है, लेट अस से A मिनिमम स्टॉप बैंड एटेनुएशन, A मिनिमम, एंड द ऑर्डर ऑफ द फिल्टर M. ओके, तो ऑर्डर ऑफ द फिल्टर जो होता है, ऑर्डर ऑफ द फिल्टर नंबर ऑफ पोल्स पे डिपेंड करता है. ईच नंबर ऑफ पोल्स will give you, जैसे अभी हमने किया था ना, we were discussing this function, ये वाला फंक्शन, ये this is all pole filter, और जो ये पोल है, this pole represents the order of the filter. अगर there is only a single pole, then it is order 1 filter. If there are 2 poles, then it is 2 order filter, and so on. Okay, and each pole will give you how many degrees? -6 dB per octave का डिक्रीज देता है each pole, या इसको हम ऐसे भी कह सकते हैं -20 dB per decade, -20 dB per decade का डिक्रीज देता है each pole. ओके, इन द फिल्टर रिस्पॉन्स. तो जितने ज्यादा पोल्स होंगे फिल्टर में, उतना ही उसका ऑर्डर जो होगा वो ज्यादा होगा, एंड मोर इट विल बी क्लोजर टू द आइडियल फिल्टर. ये हमने यहाँ पे आपको दिखाया, जैसे जैसे ऑर्डर बढ़ता है वैसे वैसे इट इज मच मोर क्लोजर टू द आइडियल फिल्टर. Okay, third year. Just having discussed this practical filter, now we can define the specification for analog filter. Specifications for analog filters. Specification for analog filter. So analog filter के अंदर क्या specifications होनी चाहिए? Of course we are discussing, let us suppose this is omega frequency and this is 1. Okay, then it will have pass band like this and stop band like this. Okay, stop band like this, and let us suppose this is the change delta P passband ripples, and let us suppose this is omega P cutoff frequency and omega S stop band frequency, and this is ripples in the stop band, let us say delta S. So what is omega P? Omega P is pass band cutoff frequency, omega S stop band cutoff frequency, delta P pass band deviation या tolerance which is allowed, pass band tolerance, and delta S is stop band deviation या stop band tolerance. Okay, stop band tolerance. So these are the parameters which can be used to define an analog filter. So when we have to design a filter, let us suppose like this, we have to find out HAS like this, yani constant divided by product of the poles like this, so that we can have a realization of the transfer function. Okay, and then we need to have specifications like this. That means what is our aim? Our aim is to determine HAS. Our aim is to define HAS, any transfer function HAS, for a given value of omega P, omega S, delta P and delta S. So delta P, these are the parameters which are used to define the filters, designing parameters. Once these have been specified, we need to find out HAS. This is how the designing an analog filter results. Designing an analog filter means finding out HAS, transfer function for all pole filter, under the given designing parameters of these 4 parameters. That means आपको जो given होंगे वो ये डिजाइनिंग पैरामीटर्स होंगे, और आपको क्या डिजाइन करना पड़ेगा, निकालना क्या पड़ेगा, आपको HAS निकालना पड़ेगा. ओके, HAS निकालना पड़ेगा. दिस इज हाउ डिजाइनिंग एन एनालॉग फिल्टर इज डन. ओके, now these are the specifications for, these are the general specification for an filter, but the easiest will be Butterworth filter. Butterworth filter की क्या easiness है? Because it do not have any ripples. It do not have any ripples in the passband. Therefore, it is easier to be defined, to be designed. Okay, so it only requires 2 designing parameters. First, order of the filter, and second, cutoff frequency. Okay, so that is why Butterworth filter is easier to be designed. So how to design an Butterworth? This is the transfer function of an Butterworth filter. Okay. So when omega is equal to omega c, the value of HA square is 1 by 2, no matter what is the order of the filter. Order of the filter may be anything, but value of HA square will be 1 by 2. Okay. So therefore it is called minus 3 dB frequency, and it is same for any order of the filter. Okay. And designing the Butterworth filter is much more easier because it do not have any passband ripples and stopband ripples. Therefore it only involves two parameters. One is cutoff frequency omega c, and another is order of the filter, that is n. Okay. So as the order changes, it reaches to the ideal response, but it is not always recommended that the maximum order should be taken, because as the order increases, number of elements in the circuit increases, and that increases the cost, and therefore the batch fabrication goes higher. Batch fabrication cost goes higher, and we need to reduce this cost. So basically it is optimization of order and complexity in the Butterworth filter. तो ऐसा नहीं है कि हमेशा हमें ऑर्डर जो है मैक्सिमम रखना चाहिए, क्योंकि जितना ज़्यादा ऑर्डर होगा कंपोनेंट विल बी उतने ज़्यादा ही होंगे, कंपोनेंट विल बी हायर एंड इट विल एड अप टू द कॉम्प्लेक्सिटी ऑफ द सर्किट एंड देयरफॉर द कॉस्ट. ठीक है. तो हमेशा हमको एक इनको ऑप्टिमाइज करना पड़ता है बिटवीन द कॉम्प्लेक्सिटी and the order of the filter. Okay. So this was the discussion for the analog filter design. Next time we will be discussing the digital filter design. Okay.